In this video, I will show you how to calculate gravitational potential energy. As you likely know from watching the potential energy video on this channel, gravitational potential energy is directly related to gravity, mass, and height. Physicists have put together a formula to calculate the potential energy of a system. Let's first dissect the formula and then do some practice problems. The formula to calculate gravitational potential energy is seen here. For every problem in which we are working with gravitational potential energy, we will use this formula. On the left-hand side of the equation, GPE stands for gravitational potential energy. The unit used to measure energy is called a joule, and it is abbreviated with a capital J. On the right-hand side of the equation, we first have M, which stands for mass, and must always use the unit kilogram, abbreviated as kg, for the formula to work. Next is G, which stands for gravity, with a unit of meters per second squared. This number is constant and depends on what planet you are calculating GPE on. On Earth, this number is always 9.8. The number will change in other planets. Finally, H stands for height, which always uses the unit meters, abbreviated as M, as a unit for the formula to work. You must always have 3 out of the 4 values in order to calculate the unknown value. Then the formula can be considered a single variable equation and can be solved using algebra. The difficulty is in identifying what information is given. The best strategy is to first read the problem carefully and then look for units. Let's practice. So let's take a look at our first problem. It says, a 75 kilogram refrigerator is located on the 70th floor of a skyscraper 300 meters above the ground. What is the potential energy of the refrigerator? So I see the words potential energy. I know to use my potential energy formula. So let's write out GPE equals mgh. So the problem is very clearly asking us what the potential energy of the refrigerator is. So we know that GPE has to be our unknown. Let's write down the variable. All that's left to do is find out m, g, and h. So first I look up top and I see 75 kilograms. That kg tips us off that we have a mass of 75 because kilograms indicates mass. Next is g. We know that g always equals 9.8 on Earth, so we can fill in 9.8. Finally, height. I notice it says 300 meters above the ground. If you see meters in one of these problems, you know you're dealing with height, so I plug in 300. Now all that's left to do is simply multiply to solve for GPE. So I'm going to write down GPE equals 220,500. So we're going to see in this next problem that sometimes we will use the gravitational potential energy formula but not be calculating GPE. So let's read this problem. A weather balloon is floating 1,200 meters in the air and currently has 10,800,000 joules of potential energy. What is the mass of this balloon? So right away we know to use the potential energy formula because we see the words potential energy. And we also see that it's asking us for mass. So let's write down our formula, GPE equals mgh. So we saw that it's looking for mass, so we know automatically that's going to be our unknown variable. So let's plug that in first. Now all we need to do is find gravity, height, and GPE. Well, looking at the top, we see 1,200 meters. If you see the word meters, you know you have your height. So let's plug in 1,200 for h. Now g is easy. It's 9.8 because gravity is always 9.8 on Earth. Finally, we need to find GPE. I see the letter J indicating joules, so I know to fill in 10,800,000 joules for GPE. Now I'm going to simplify the right side of this formula by multiplying 9.8 times 1,200. That's going to give me 11,760 m equals 10,800,000. So now we simplify the problem further to isolate m, divide both sides by 11,760. That will cancel out on the right side, isolating m, and on the left side, we'll get our answer, which is 850.4. So let's go ahead and read our last problem. A cart is loaded with a brick and pulled at a constant speed along an inclined plane to the top of a mountain. If the mass of the loaded cart is 3.0 kilograms and the cart has 13,023 joules of energy at the top of the mountain, then how high is this mountain? So this problem tries to trick you by talking about a moving cart, which often indicates kinetic energy. However, when I see the words height of the mountain, I know we must be dealing with gravitational potential energy. So let's go ahead and write our GPE formula. GPE equals mgh. Now, the problem is asking how high the mountain is, so I know h must be our variable we're solving for. So now let's find our unknown information. Well, we know that g has to equal 9.8 because that's our gravity, always on Earth. M is going to equal 3.0 kilograms, the clue being kg. So let's fill in 3.0 for M. Now for GPE, we see joules, indicating that 13,023 is our amount for GPE. So let's simplify the right side by multiplying. 29.4 H equals 13,023. And now we have to simplify even further to isolate our single variable. Divide both sides by 29.4. Cancels out on the right side. This gives us 442.9 meters as the height of our mountain.